Okay, a 1.5 meter long rope is stretched between two supports with a tension that makes the support speed of transverse waves 62.0 meter per second. What are the wavelengths and the frequency of the fundamental, the second overtone, and the fourth harmonics? So these are the things we have to calculate. So the fundamental frequency and the fundamental wavelength, the second overtone, that means the third harmonics, and a fourth harmonics, this means a third overtone. Okay, so we have given here the length and uh, speed of transverse wave in the rope. Okay, so rope is like this. It is supported by two supports like this, and its length is, which is, we can say this is L is 1.5, 1.5 meter long. When wave is traveling, if you plug this rope, it will generate a wave which will travel like this, right? This is the fundamental wave, fundamental frequency condition, which is fundamental, right? The minimum frequency possible in this rope will be this one. Okay, so given in this problem, we have two things. One is length 1.5 meter, which is length of this string, and the other is speed of wave generated in this rope, which is 62 meter per second. In 1 second, wave is traveling 62 meter per second. So we have to find the fundamental frequency and the fundamental wavelength and the frequency for the fundamental, okay, which is the minimum frequency or wavelength that is possible here, and the second overtone, third harmonics, it is also said to be third harmonics, and the fourth harmonics, which is third overtone. Okay, so lambda 1 is equal to what? F1 fundamental frequency, fundamental wavelength, third harmonics, which is third harmonics, the wavelength for third harmonics, and third harmonics, the frequency, and fourth harmonics or third overtone. Okay, this is third overtone, this is second overtone. Okay, F1 is the fundamental, and F2 will be the uh, first overtone, first overtone. Okay, so what is the concept to solve this problem is, we have a relationship between wavelength, the length of the string or rope, and the frequency and the velocity. Okay, so we know the relationship between lambda, that is wavelength, and the length is lambda n for the nth wavelength is related with length by 2l divided by n, and frequency is fn equal to, for nth frequency, n velocity, speed of the sound wave there, divided by 2l. Okay, so this 2l is actually the fundamental frequency, right? Lambda 1 is equal to 2l. Okay, so going back to mathematics, for the fundamentals, n is equal to 1. The value of n will be 1 for the fundamental, right? Below that, the wave cannot be possible. Okay, so putting in this equation, n is equal to 1, and this equation, you will get lambda 1 equal to 2l. Okay, we already have l, the length of the rope. When you insert this value over here, we will get the wavelength of the fundamental, which is 3 meter. Okay, similarly, to find the frequency, the fundamental frequency, when you insert n equal to 1 in this equation, n will be 1, and going down here, f1 will be equal to, when putting 1 here, you can erase this 1, right? And b equal to 2l. Okay, b is given, we have 62.0 meter per second, and L is 1.5. So when you calculate this one, inserting in this equation, 2 into 1.5 will give you 3, and finally F1, which is the fundamental frequency, will be 20.7 hertz. Okay, and the second one in part B, we have to find the same thing, I mean wavelength and the frequency for second overtone. In second overtone, n will be 3. Okay, so for the second overtone, n is equal to 3. Putting 3 in above equation, you will get lambda 3 will be lambda 1 by 3. How can you get it? So actually lambda 3 is equal to 2L by 3, right? Lambda 3 is equal to 2L divided by 3. But what is 2L? 2L is actually lambda 1. So we will get lambda 1 divided by 3. Okay, so we already have lambda 1. Putting value, inserting value for lambda 1 here, we will get 1 meter. So wavelength for second overtone is just 1 meter. To find frequency for second overtone, in the equation here, insert n is equal to 3, fn equal to nb by 2l, right? f3 equal to 3b by 2l. But what is b by 2l? This is f1. Okay, so this quantity right here is f1. So f3 will be 3f1. Okay, so inserting this value, you will get 62.0 hertz, which is the frequency for second overtone. Similarly, the third overtone, or we can say it fourth harmonics, for that n will be 4, n is equal to 4. So inserting n equal to 4 in above equations, you will get lambda 4 equal to lambda 1 by 4, and inserting this value, lambda 1 is 3 from part A, we will get 0.75 meter, right? Similarly, the frequency of 4, which is frequency for third overtone, is 4 multiplied by f1, 4 times the fundamental frequency. You will get this value, 82.7 hertz. Okay, if you look at this pattern, what you can see here is interesting. What is happening with frequency and wavelength while we move from fundamental to the higher harmonics or overtones. Look at from here. First, let us compare wavelength. Wavelength lambda 1 is 3. Wavelength for second overtone is 1, 3, 1. And wavelength for third overtone is 0.71. Look at here. Lambda 1 is 3. Lambda 2, not lambda 2. We haven't calculated that. Lambda 3 is 1, it's in meter, and lambda 3 I think is lambda 4. Lambda 4 is 0.75. What is happening here? It is decreasing, right? While you are moving from here to here, moving from lower to higher wavelength, overtone, the wavelength is decreasing, it's going down, right? So what is happening with frequency? Let's compare that one. Go to the first one, frequency is 20.7, and in second one 62. Okay, so fundamental frequency is 20.7 hertz. Frequency for second overtone is 62 hertz, and that for third overtone is 82.7 hertz. Okay, so when you move from f1 to f4, frequency is increasing. This is just 23 times and 4 times. Okay, so wavelength is decreasing, frequency is increasing. We know wavelength is inversely proportional to frequency because speed of sound remains constant.